Hey everybody, and welcome to this video on multiplying polynomials. So without further ado, let's make it happen. Alright, now before we go ahead and multiply polynomials by polynomials, I want to look at a couple real number multiplication problems to show that the strategy for doing this multiplication is exactly the same strategy for doing polynomial multiplication. So for instance, if I asked you to multiply 14 by 16, you might have an algorithm by which to do it, or maybe you can do this mentally using some tricks. And one way I really like to think about 14 times 16 is with a rectangle, who has one side of length 14 and one side of length 16. In this case, the area of this rectangle should be 14 times 16. However, that's a pretty difficult multiplication to do. So what I want to do is break up 14 and 16 into 10 plus 4 and 10 plus 6. And note, this is the exact same multiplication problem as we had originally, we're just writing it a little bit differently. So now if we look at our rectangle, we actually have 4 smaller rectangles. And if we sum up their areas, we should get the total area, or 14 times 16. So let's go ahead and do it. First we get this 10 by 10 square, who's got an area of 100. Then we get this 10 by 6 rectangle, whose area is 60. Then we get a 4 by 10 rectangle whose area is 40. And lastly, we get a 4 by 6 rectangle whose area is 24. And so we end up with an area that's the sum of 100, 40, 60, and 24 for a grand total of 224. Now note, one way to make a connection between the rectangle and the math that's written on the left is note that what we did really is we took this 10 and we first multiplied it by 10 and then we multiplied it by 6. It's as if we distributed that 10 to both the numbers in the second set of parentheses. And then we took this 4 and we multiplied it by both the 10 and the 6. It's like we distributed that 4 to both numbers in the second set of parentheses. And what did we end up with? Well, we ended up with 100 plus 60 plus 40 plus 24. And what do those sum to? 224. Our product when we multiply 14 by 16. Let's try another one. 134 times 26. Now if I ask you to multiply those two, maybe you've got an algorithm by which to multiply a 3-digit number and a 2-digit number. Maybe you have a tricky way of doing it in your head. What I like to think about is a rectangle who has one side of length 134 and one side whose length is 26. So the area of this rectangle should be 134 times 26. But again, that's a really tough multiplication problem to do. So what I like to do is break up 134 into 100 plus 30 plus 4. And break up 26 into 20 plus 6. Alright, now let's go ahead and multiply some polynomials. And this is going to be a direct extension of what we just talked about. For instance, in our first example, all we've got is one number plus another number times one number plus another number. It's no different than, for instance, 10 plus 4 times 10 plus 6. We're going to handle it in exactly the same way. Once again, the way I like to think about this is with a rectangle who has one side of length 2a plus 1 and one side of length a squared plus 3. Now, the full rectangle is made up of these 4 individual rectangles. So if we can find their areas, we can find the areas of the whole. Well, those 4 areas shouldn't be so bad. This upper left rectangle is going to have an area of 2a to the third power. The lower left-hand rectangle is going to have an area of 6a. The upper right rectangle is going to have an area of a squared. And the lower right rectangle is going to have an area of 3. And so we find that the total area for this big rectangle is 2a to the third plus a squared plus 6a plus 3. What did we do there? We multiplied this 2a by both a squared and by 3. Then we took this 1 and we multiplied it by a squared and by 3. Looking at the math, we distributed that 2a to both a squared and 3, and that 1 to a squared and 3, and of course, this is the product we got. Once again, in general, we want to make sure that our final product is in standard form. This one isn't quite there yet. In this second example, it's going to be the exact same strategy. I like to visualize this as a rectangle who has sides of length 3m plus 4 and 2m plus 3. And so the area of this rectangle will be the product of 3m plus 4 and 2m plus 3. And of course, this larger rectangle is made up of 4 smaller rectangles. So if we can find their areas, we can find the area of the total. The upper left rectangle has an area of 6m squared. The upper right rectangle has an area of 9m. The lower left rectangle has an area of 8m, and the lower right rectangle has an area of 12. And so, the product of 3m plus 4 and 2m plus 3 should be 6m squared plus 9m plus 8m plus 12. What did we do? I think we took this 3m and we multiplied it by both the 2 and the 3. We distributed it to both numbers in the second set of parentheses. I also think we took this 4 and we multiplied it by the 2m and the 3. We distributed it to both numbers in the second set of parentheses. And of course, this is the product we ended up with. And in general, we want to make sure that we collect all our like terms and that we're in standard form when we're all done. So the only thing I think we have left to do is to collect these two like terms. And our final product will be 6m squared plus 17m plus 12. And our strategy remains exactly the same, even when we got crazy things like trinomials involved. We take every term from the first polynomial, and we distribute it to every term in the second polynomial, and we add up all the resulting products, and we collect our like terms, and we put our final product in a standard form. So again, for this example right here, I like to visualize it as a rectangle who has one side of length 2x plus 2, and the other side of length 4x squared plus 4x plus 2. And of course, we've got 6 small rectangles, and if we sum up all their areas, we'll get the total area. Well, the top left rectangle has an area of 8x to the third power. The middle left rectangle has an area of 8x squared, and the bottom left rectangle has an area of 4x. The top right rectangle has an area of 8x squared. The middle right rectangle has an area of 8x. And the bottom right rectangle has an area of 4. And so, the product of 2x plus 2 and 4x squared plus 4x plus 2 will be 8x to the third plus 8x squared plus 4x plus 8x squared plus 8x plus 4. What did we do? Again, I think we distributed this 2x to the 4x squared and the 4x and the 2. I also think we did the same thing with this 2. We multiplied it by the 4x squared, the 4x, and the 2. Now, you may be wondering, why did I write these terms kind of staggered right on top of one another? What's really nice is that when you multiply one polynomial in standard form by another polynomial in standard form, it makes it really easy to line up your like terms if you just stagger them a little bit. And so, collecting our like terms and finding our final product in standard form becomes so much easier. I've got all my x squareds in a nice column, I got all my x's in a nice column. It's really easy to find our final product. Just a little trick I like to use. Now, when there's subtraction involved, like in this next example, it's a lot harder to draw with a rectangle, but the strategy remains exactly the same. We're going to take every term in our first polynomial, distribute it to each term in our second polynomial, and sum up what we get. So for instance, let's start with this 2m squared. We're going to multiply it by 3m and by negative 4. So we get 6m to the third minus 8m squared. All right, now let's take this negative 5m. We're going to multiply it by the 3m and the negative 4. Negative 5m times 3m is negative 15m squared. Negative 5m times negative 4 is positive 20m. And note how I'm lining this up, so I'm going to have all my like terms right on top of one another. Pretty snazzy, huh? And then I'm going to multiply the 6 by the 3m and the 6 by the negative 4. 6 times 3m is 18m, and 6 times negative 4 is negative 24. And so finding our final product will be no problem at all. Our final product is 6m to the third minus 23m to the second plus 38m minus 24. Alright, so now that we know how to multiply polynomials, a couple tricky things to watch out for. So what happens if we've got three polynomials being multiplied by one another? Well, imagine I asked you to multiply 3 times 4 times 5. I bet you'd probably multiply 3 times 4 together and get 12, then multiply 12 by 5 to get 60. Or maybe you multiply 4 times 5 first and get 20, and then multiply 3 by 20 and again get 60. Now it's the same exact idea. If we're multiplying three polynomials together, just multiply 2 of them first, you get another polynomial, and multiply that by the remaining third. So in this case, let's multiply 3g plus 2 times g squared minus 1 first. We're going to multiply 3g by g squared and 3g by negative 1, and we get 3g to the third minus 3g. Then we're going to multiply 2 by g squared and 2 by negative 1. We get 2g squared minus 2. All right, and we're going to take this big old polynomial and we're going to multiply it by 2g plus 5. Is it going to be a whole lot of steps? Yeah. Can we handle it? Totally. If you'd like, you can multiply it as is, or what I like to do is I like to put this polynomial into standard form first to make things easier later. Alright, so first we're going to multiply the 3g to the third by 2g and by 5, and we end up with 6g to the fourth plus 15g to the third. Then we're going to multiply 2g to the second by 2g and by 5, and we end up with 4g to the third plus 10g squared. Then we're going to multiply negative 3g by both of these, and we end up with negative 6g squared minus 15g. And last but not least, we're going to multiply the negative 2 by both of these, and we end up with negative 4g minus 10. Now, I kind of went a little over the top with all this staggering, but you got to admit, it makes it really easy to collect your like terms later. And so our final product in this case will be 6g to the fourth power plus 19g to the third plus 4g squared minus 19g minus 10. Alright, last tricky thing to keep an eye on. M plus 5 quantity squared. It is so tempting to think that this is going to be m squared plus 25, but it is not. It is absolutely not equal to that, so don't make that error. What does it mean to raise something to the second power? It means multiply that thing by itself 2 times. So this is going to be m plus 5 times m plus 5. And I'm sure you know how to multiply this. We're going to multiply m times m and m times 5, m squared plus 5m. And then we're going to multiply 5 times m and 5 times 5. And we get another 5m and 25. And our grand total in this case is m squared plus 10m plus 25. Yes, we did get an m squared. Yes, we did get a 25, but we also had this 10m in the middle. So don't make that careless error in the future. If the original question were slightly different and it were 5m quantity squared, note that it's just multiplication within the parentheses, and that allows us to go ahead and quote-unquote distribute this exponent to both of them, and then you would get a 25 and an m squared. But still, a totally different type of problem. Alright, time for some practice. Why don't you pause the video and please multiply these 4 polynomials, making sure to collect like terms and put your final product in standard form for each one. And when you're done, play the video and we'll see how it went. Alright guys, that's it for this video. I hope you enjoyed and I hope you found it helpful.